Students and friends, welcome to my YouTube channels. Today I brought one new problems for you. These problems generally they are asking university exam also and GATE exam, any competitive exam or railway exams, whatever competitive exam you will write, like this problems will be there. This problems belongs to the engineering mechanics. So what they are asking, find the reaction at the support A. This is the support, fixed support here of the rigid frame. This is the frame. What is given in the figures? What is given here? A to B. You see, you are seeing this now. This is called UDL, uniformly distributing load. This is the given UDL here, uniformly distributing load. Then one point load is there, 80 kilonewton, and one inclined load is there at point C. So how to solve this? You have to find the reactions at point A only. So see, some basic concept will be there. Always I am discussing basic concept. If basic concept you will know, you can easily find and you can draw the free body diagram and find the reaction at point A. So what we have to see for here? So okay, first this inclined force C is there. So I will resolve, because already you know horizontal force only one force will be there. Vertical only one force will be there, but inclined having two component. So how this component will break? Lot of times already we discuss. So how will break this? See the line and all. So how will break? So see here, I will draw this for your personal information. Suppose this is given like this 20 degree, like this force is given. This is 20 degree. Now inclined force how will resolve? With respect to horizontal, we will draw one horizontal line. This is one resolution. And if we will draw the perpendicular line here, this is the resolution of these forces, 60 kilonewton forces, resolution of this. Now this will be the horizontal force, will act at the point, horizontal force will act at point here. So how much this one? This will come 60 cos 20, because this angle will be 20, this angle also will be 20. So already told, near angle always cos component and far angle from this 90 minus 20, or this you can write sin 20. So you can write 60 sin 20. Okay. So this, what will be the value that we will write here? So 60 cos 20 value will come, we calculated here 60 cos 20 value is coming 56.382. 56.382. So in calculator cos, operate the cos, then 20, bracket close, then into 16, and this will come. So here what is coming? Horizontal forces 56.382 kilonewton, because 60 kilonewton given, so this is the kilonewton horizontal force. Then vertical force 60 sin 20, this value is coming 60 sin 20 value is coming 20.521 kilonewton. This will act in this point C. Suppose this point C, so it will act at point C. What is this one? 20.521 kilonewton. So C point work over. So inclined force is there, one horizontal, one vertical forces, we resolve it. Now 80 kilonewton is there after 1 meter. So we will draw the 80 kilonewton. 80 kilonewton, this distance given 1 meter. The distance given 1 meter. Now we have UDL. What is the concept of the UDL here? Suppose UDL will be there. Either UDL symbol will be this, or UDL symbol will be this. Uniformly distributing load. This is called UDL. Nothing but uniformly distributing load. This is called UDL. So per unit length, like this will be there. So once UDL UDL will be there. What will the load here? Load will be nothing but because rectangular what is area into length into breadth. So load will act in the middle point. Why it will act in the middle point? Due to the UDL load deflections will be maximum in the middle. That means due to the UDL, if you draw the load diagram, load will act. Suppose this is here W kilonewton per meter. This is length L meter. So this load will come W into L. So length into breadth, length into breadth. So UDL area of the rectangle W into L. This load will act at middle L by 2 distance. So similarly you see here UDL is there 6 meter length, 5 kilonewton per meter they given the UDL length, uniformly distributing load. Now where it will act? It will act in the middle. It will act in the middle. How much it will be there? 5 into 6 equal to 30 kilonewton. Because kilonewton per meter into 6 meter. Meter cancel kilonewton. So where this will be, what will be the distance here now? Distance will be 3 meter. Because I already told load will act at the middle. Load will act at the middle only. UDL load will act in the middle only because UDL is nothing but rectangular load. Or also you can say center of gravity point. Once moment also will take na. Now this is force into perpendicular distance. WL into L by 2 moment about, suppose this point A, this point B. If you take moment about A, W into L force into perpendicular distance, W into WL. This is called moment per particular point. So now this free body diagram here I draw. Now you given here 10 kilonewton, one more load in the top. They given 10 kilonewton load, and this distance they given 2 meter. This distance they given 2 meter. This distance is 1 meter. So now this is the free body diagrams we draw. Seeing this, we draw the free body diagram. This is the point A. So this is the fixed, this point A. Now suppose fixed beam will be there. Suppose this beam is fixed beam. So then hinge, then roller. So what you have to know here? Fixed beam, 3 reactions force will act. VA, VH and moment A. 3 reactions force will act. VA, VH, hinge na VH and VB, VA. Roller na only VA. Roller support means only VA. So this is the reaction force you have to know. Fixed beam, 3 reactions. Vertical, horizontal, moment. Hinge support, hinge. Vertical, horizontal. Roller only vertical. Here what is there? Fixed. So how many forces will act here? Vertical force will act VA. Horizontal force will act HA. And moment will act MA. 3 reaction force will act at point A. At point A. Now this is the complete free body diagram. If this basic concept you know, now 2 or 3 steps we can solve the questions. So okay. So like these questions, if you are understanding, I already uploaded 3 to 4 questions like this. So some questions like UDL will be there, UVL will be there, combined UVL will be there. So all the basic concept I explained. Suppose this 5-6 video already we did before this video. Suppose you will watch all the video, whatever questions will come for finding the support reactions, you can easily handle. You can easily find out the answer. So this is the basic concept you see here. All we did. Now we will apply the 3 equilibrium equations in this free body diagram. So 3 equilibrium equations will apply in the free body diagram. So these things are the concept. These things are the concept for you. These things are the concept. These are the concept you have to always remember. So each and every problem we are giving this concept here. So we will apply the equilibrium equation. So what is first equilibrium equation? Summation Fh equal to 0. That means total leftward force equal to total rightward force. Always we are using like this. So total leftward force equal to total rightward force. We will see how many leftward force is there, this is HA. So HA 30 10 going this way. So what is there? HA plus 30 kilonewton plus 10 kilonewton, 1, 2, 3 horizontal force. Any leftward force going? No. Now rightward force what is? 56.382. So this is the first equilibrium equations came. So HA is equal to how much will come now? HA is equal to 56.382 minus 3 plus 10, 40. It will go this side, so minus. So this will come 16.382 kilonewton. So now you know HA. HA, how you know? 16.382 kilonewton. Now we will go the another equilibrium equation. Sigma FV equal to 0. Now what we are considering here? We are considering total upward force equal to total downward force. Very simple concept. Or upward force minus downward force equal to 0. So summation of all the vertical forces equal to 0. This is the concept. So we are taking just next step. What is? Total upward is equal to total downward force. So should not consider negative and positive. So we will see upward force what is? MA. As a MA, VA. This is MA moment. You write here. MA moment, VA. Vertical force what is? VA. Any vertical forces is there? No vertical forces. So VA is equal to 80 plus 20.521. 80 plus 20.5. So two vertical forces will be there. So VA how much will come? It will come 100.521. It's coming 100.521 kilonewton. So we know the two forces we know now. We know the HA, we know the VA. Now we'll go the moment. Summation of moment A equal to 0. Under this what we'll do here? Under this we'll do total clockwise moment is equal to total anti-clockwise moment. So now we'll look here. Rotations will show you. So it will be easy for you. We are taking moment about A. That part only, those having less concept, you see again. One in this point moment MA is there. This moment what is? This is moment is anti-clockwise. This moment is there ACW. Due to this point is rotate like this. This is the A point fixed. This will rotate like this. What is this one? Rotations will be, you write here, clockwise. Due to this, rotations will be clockwise. Due to this, rotations will be clockwise. Due to this, rotations will be clockwise. Due to this, see this force will act up to here. So what is distance? This is the perpendicular distance, this is the force. So this force will rotate. This force will rotate here, 56. So this is 56.382 into 6. So for this will be ACW. Now look why I told. Because taking moment about this. So this force will act in this point. So this 56.382 horizontal force anywhere will be the same. So that rule is that's called transmissibility. So what is the transmissibility? See, suppose one force acting F1 here. Now this force will come here, this is F1 here. So anywhere this force will come, F1 here. So what transmissibility telling? If position of the forces changes anywhere in the same line of action, magnitude will not change. That is called transmissibility. So listen here, if the position of the forces changes anywhere in the same line of action, this is the line of action, same line of action, magnitude of force will not change. So now once you're taking moment about A, no? So this force, it will come here and this point, this line, it will rotate. How much? Force into perpendicular distance. Force into perpendicular distance 6. That only you have to remember. Now everything I wrote here. What is clockwise, what is anti-clockwise? Just you write, you will get the answer. So moment only little difficult. So what you do? All the basic used and give the rotations everywhere. Due to this point, which force rotate where, which force rotate here, which force will rotate here. Then you write only clockwise. How many clockwise? Clockwise you see here 30 into total distance. How much? 3. So we'll write here 30 into 3. 30 into 3 plus next 10. 10 into total distance. How much? 6 plus 80. 80 force. Total distance 2. So 80 into 2 plus 20.52. 20.521 into distance. This distance only 3 equal to clockwise, sub 4 over. Now anti-clockwise. What is this one? 56.382 into 6 into 6 plus again anti-clockwise MA. Again anti-clockwise one to MA. So this is the moment. Now you look here again. 30 into 3. 10 into 6. 80 into 2. 20.521 into total distance is 3. And this moment will be perpendicular distance is this only. Because about this force will act up to here. Then this is the perpendicular distance. Now one step I'll write. How much calculations will be there? 90 plus 60 plus 160 plus 20 into 521 into 3. It is coming 61.523. Yeah? 563 equal to 56.382. This coming 338.292. 338.392 plus MA. I think so, no? This is coming. So MA is equal to, now finally MA is equal to this total length, total calculus will be 90 plus 60, 150, 150 plus 60, 371. It is coming 371.563 minus 338.392. So this value is coming 33.271. 33.271 kilonewton. That is called MA. MA. So now we know this. See all the reactions. Find the reactions at the support A. What is the reaction of support A? HA will be 16.382. VA is equal to 100.52A. MA is equal to, this is the value you getting. So okay. So once we will check 30 into 3 90, 10 into 6 60, 80 into 2 160, 61.563. If we'll see this coming 371.563, this is 563. Now minus this 56.382 into 6 coming 333.292. This is coming 0.292. This is coming 338.292. 371.563. It will subtract 33.271. So this is the complete solution. This is the complete solutions for you. So now look here, how many things you have to remember. This only basic concept, if you are able to remember, apply this equilibrium equations, we get the reaction at point A. So like these questions, if you practice, lot of other also doubts will get clear. Okay students, watch this video, subscribe the channel, share this video to your friends. Okay, thank you.